So today's lesson is on literal equations. Our objective today is students will be able to isolate a variable in a literal equation. So what is a literal equation? Well, a literal equation is an equation with two or more variables. You can rewrite a literal equation to isolate any one of the variables using inverse operations. This is called solving for a variable. So essentially what we're going to do is we're going to say solve for x, and there's going to be a whole bunch of stuff there. And what you're going to do is you're going to rewrite or move things around so that x is by itself on one side. Now you won't always be solving for x. I'm using that as an example. The problem should tell you which variable you're trying to get by itself. You have to pay attention to that. When you rewrite literal equations, you may have to divide by a variable or variable expression. In this lesson, assume that the variable or variable expression is not equal to 0. Division by 0 is not defined. So in math class, you can never divide by 0. This rule will come a lot more into play in Algebra 2. We're not going to get really into that this year, but I'm throwing it out there so you've at least heard it. So when you get to Algebra 2, it'll be like jogging your memory. All right, so an example of a literal equation would be like the circumference formula, where c equals 2 pi r. So you can see we'd have a c, we'd have a pi. Pi counts as a letter or a variable, even though we sort of know what it's equal to, and r, which is for radius, which hopefully people know. All right, this is how we solve for a variable. Step 1, locate the variable you are asked to solve for in the equation. Step 2, identify the operations on the same side of the variable in the order in which they are applied. Step 3, use inverse operations to undo operations and isolate the variable. And when you use those inverse operations, it's the same as with a regular equation, where you're going to go the opposite of the order of operations.
If you go back to step 1, once you find the variable you're looking for, circle it. Keep it circled until it's totally by itself. That way you don't mess up on which variable to solve for. Circle the one they ask you to solve for right away.
Absolutely. So example number 1, solving literal equations. So solve x plus y equals 15 for x. So our goal is to get the x by itself. Our next big unit that's going to be coming up in probably about 2 or 3 weeks, maybe somewhere around there, we're going to have these types of equations. These are linear equations, meaning you can graph them as a straight line. But because there's 2 variables, you can't get the kind of answer of x equals 3. Or x equals 5. We're going to get something that looks a little more complicated. The important part is to get the x by itself. Okay, so step 1 is to locate the x. So I see that the x is right here in this equation. So I went and I highlighted it in blue. Circling is good. But I didn't like the way the circles looked on the PowerPoint. It made it kind of look a little weird. So I highlighted it in blue. It's important to make sure you're pointing out to yourself where this variable is. I can't tell you how many students over the years have isolated the wrong variable, where they did a great job isolating something, but they picked the wrong letter. So it's important to make sure you're focused on the letter you're supposed to solve for. So since y is added to x, we're going to subtract y from both sides to undo the addition. So we subtract y from both sides, and we get x equals negative y plus 15. You also could write it as 15 minus y. That's fine. But remember that the minus sign goes with the y. Don't do y minus 15. Got to keep the signs with the right term. And this will be your whole answer. Let me go back. I thought I had another slide for this. This will be your whole answer because you have x by itself. and what it's equal to. It's on the other side.
Could you explain it a little more of why you switched the plus sign and the equal sign?
Because you're doing inverse operations. If there's an addition in the front of that letter, you have to do the opposite, which is subtraction. If that would have been x, if that would have been x minus y, then you would have put plus y on both sides. So that's what I was saying about 10 minutes ago. The process for solving equations that you guys have been doing for 3 weeks, we are still doing the same thing, except now you're moving letters around instead of just numbers.
Okay, thank you. I understand.
And we're going to do more examples. So, you know, hopefully, and again, we're going to spend a second day on this. So, you know, it's okay. We're going to take it nice and slow. Hopefully everybody will get a chance to, you know, figure it out.
You guys won't see this again until next Wednesday.
Yeah, next Wednesday we have to take a test.
Yeah, so next Thursday will be the second day on this.
Yep. All right, so here's another one. I've been keeping them really simple at the beginning, where these are just one-step literal equations. So we have solve PQ equals X for Q. Okay, so we follow the same exact steps. We're going to locate Q in the equation. And you can see I rewrote the equation and I highlighted the Q in blue. Now, you don't have to rewrite your equations when you're doing this. You can just circle it here. That's fine. But I put it down here so you guys could really see it. It's, you know, isolated from everything else. And we see here that we have 2 letters right next to each other. So we're going to go ahead and we're going to multiply. We want to get rid of that multiplication. So we go ahead and we divide. So we would divide by the P, because the P is what we're multiplying the Q times. So we divide by P. And these P's cancel out. It's just like the number. So when we have a 3 in a letter, for example, and we divide by 3, 3 divided by 3 gives you 1, because anything divided by itself is 1. It's the same idea here, P divided by P. You're still dividing something by itself, so it turns into a 1. And when you have 1 times anything, it doesn't change whatever that thing is, in this case, Q. So 1 times Q is still just Q. But the X and P can't simplify because they're not like terms. We don't know what X equals. We don't know what P equals. So we're done. That's all you can do with this problem. Okay, you guys are going to try one. You have X plus A equals B, and you're going to try to solve for X. Okay, so we have X equals negative A plus B. That's perfect.
I wasn't finished.
We're going to continue on. X equals B minus A. That's okay. You can write it like that. You kept the sign with the right letters. That's good. Good. The people, you're missing a negative sign on your A. Remember, you're subtracting, but otherwise that's good. You got it to the right side. We don't want to divide them. We would divide by B if, well, B's not even on the same side, but we don't see multiplication. We see addition. So we want to do the opposite, which is subtraction. And we're missing the A altogether down here. But overall, you guys did a good job with that. So very nice. All right, let's look at another one together. I put the whole thing on one slide this time. So we have solve 5 minus B equals 2t for t. So again, I rewrite it and I highlighted the t in green so that it stands out. And I want to look, make sure if you have trouble seeing the sides of equations that you draw a line down the middle so you can see what's on each side. This becomes especially true when you see your variable on the right side. A lot of students don't like that. So on the same side as the t, we have a 2. And the 2 is right next to that t. So I need to divide everything by 2, which means the entire left side has to be divided by 2. You can't just divide 5 or the negative b. You've got to do the whole side. And after you do that, these 2's cancel out, and you're left with t equals 5 minus b, all of that over 2. And that's your final answer. Because again, your goal is just to get t by itself. That's the whole thing we're going for here. All right, so you guys are going to try one. So 2t minus 3 equals 5y, and you're solving for t. I'll give you a few minutes to go ahead and give that a try, and then we will go over it. And yeah, so this would be the solution for this. Does anyone have any questions? Okay. So let's look at another one. This one's got a little trick to it. So d equals m divided by v for v. So when you have a letter that's on the bottom, that's not a good place to be. So we found our v, it's on the bottom of this fraction. And remember, fractions are just division problems. So to get rid of a division problem, we would want to multiply. So I'd multiply both sides by v. So these v's would cancel out, right? So you'd have m equals vd. And this is the v we want to worry about. And so now we have two letters next to each other. So we divide by d because we want to get rid of that multiplication. And we get v equals m divided by d. So remember, when you see a letter on the bottom of a fraction, you have to multiply by it to get it up on top. You want your letters, variables, to be, you know, on the top of fractions or just even with everything else, like it is right here in this step. Everything is on the same level.
It's the same thing when the variable you're trying to get is on the top too. You still multiply?
No, if this one was like this, d equals v divided by m. By the way, this is the scientific formula for density. Density equals mass divided by volume. But let's say it was this. If we wanted to get the v by itself, actually you're right, we would multiply by m, but we wouldn't multiply by v. We'd leave that alone. So it would end up being v equals md.
I get it. Thank you.
Mm-hmm. All right. So go ahead and solve for this one. You have wv divided by r equals t, and you're going to solve for r. All right, so let's take a look at this one. So I see some people got it, which is great, but some people got a little confused. So let's take a look. So we have wv divided by r equals t. All right, so I want to find my letter, which is r, so I'm going to circle that. And everyone's going to remember what Miss Chickanetti just said about getting that off the bottom. We're going to multiply both sides by r. All right, so that cancels it out on this side, but it adds it to the other side. And it should look like this at this step. T, R. Okay, and I'm going to circle that again so I keep track of it, especially since it moved. Okay, and what's over here bugging this R? Well, there's a T next to it. And they're right next to each other, so they're multiplying. So I want to go ahead and I want to divide. So I end up with R equals WV divided by T. And some of you got it. Some of you did a great job on this. And some of you were really close. You got a little bit flipped. I saw a few people had T divided by WV. So somewhere you got flipped around. So hopefully that makes it a little bit more clear. And remember, we're going to spend at least one more whole day on this before we take our little exit ticket assessment. So, you know, we'll keep talking about it. And you can, of course, always email us about questions you might have. Yeah, so moving along. So to sum up our lesson for today, a literal equation is an equation with multiple different letters in it. To isolate one of the variables, first you're going to locate the variable in the equation. And Mr. Emblich and I both highly recommend you circle or highlight, do something to make that variable stand out so that you remember which thing you're trying to get by itself. You're going to identify the operations that you see, and you'll do the inverse operations to move the other terms and numbers to the other side in the reverse order of the order of operations. So it's a lot like a regular equation, except at the end you're going to have a letter equals and there'll be a whole bunch of stuff on the other side. It won't just be a number now. All right, let me know, how do you feel about today's lesson? And we will have a couple minutes at the end to go over the things I need you to do before we do the testing on Wednesday. Okay, and hang on. Okay, so we have a good mix on how people feel about today's lesson. So I want the people to know that are not feeling so hot about this. You're not alone. Some of your classmates feel the same way. We're going to do another day of it. You can ask questions and we'll get you squared away. But speaking of questions, feel free to leave me a question here about today's lesson if you have any. And I will go over whatever questions you ask on Thursday next week. Because Wednesday we're going to be taking the Pearson test. And on Monday we don't have school. And please,
do we have school
restrict
Friday?
your questions to serious questions. You do not have school tomorrow because teachers have a PD day, and you don't have school on Monday because of Yom Kippur. Okay, when you have finished answering or putting in any questions, you can exit the Pear Deck. And then I want to talk about the test we're going to take on Wednesday. So I'm going to give people a minute to get squared away.